So you want to create a sketch on this plane, and then we can push P for that, so we draw perpendicular lines. Doesn't really matter. And then constrain them to perpendicular. Oh, it's already been applied. Perpendicular, that to there. It's already done. And then same up here. And final line. Perpendicular. And then draw the nut recess perpendicular to that. And close the sketch. Finish the sketch. Looks a bit rough, but it'll work for our purposes. Select those, push extrude, look at it from home position, drag it across, and we now should have the tuttle recesses. So that means we can put nuts here onto the threaded rod, and then another nut down here. So what we want to now make is the embedded nuts, so these nuts can pull against. So we want to bring that tuttle bolt hole sketch up again, and the construction plane we built it on. So select that construction plane, create another sketch, P, so I get exact positioning. So select the circle, P, create circumscribed polygon, and the polygon, you want the flat edges along the axis of the fin, is 5.2, I think it is, radius for the nuts I have. And then create another one over here. .2, because that's going to give 0.4 clearance on a 10mm nut. So finish that sketch. Select that sketch, push E, scroll out a bit. Then what you want to do is start with an offset, and the offset's going to be around about -100, I think, and you want to go about -8mm, or not 80, 8mm. That's too far, not 190, 100. So that nut's a bit too close, so we want to go a bit further. 150, so roughly maybe 145. You can fiddle with that. So that'll be the first nut recess. Better write embedded nut recess. Put that cut out. Then select that bit there, push extrude, E for extrude, offset, so it's going to be again -100 roughly, and then -8 a bit further. So that's roughly where we want it. And right, now we're going to punch the holes for the carbon stiffeners if you want to use them. So create a sketch on the vertical plane. I typically push line or push L, and I usually do the one to the tip first, and so you want to draw your line where you want the rod to go. I'm just going to do 2 rods to show you the basic idea. You do as many as you want. So do 2 lines, make them parallel, select the one you want everything else parallel to first, and then select parallel. You can move this second line around, or the first, do whatever you want, position them where you want your tuttle, and then draw a perpendicular line and finish the sketch. Select that line, construct plane at an angle, 90 degrees. Then on that plane, create a sketch, and then you want to project those lines onto your sketch so you get these dots, and then we'll probably drill a 3.5mm hole for the 3mm rod going to the tip. So draw a circle that diameter, and let's say we'll drill an 8.4mm for an 8mm rod there. So finish the sketch, hide that other, and put carbon rod holes. So select that sketch, push E. Oh, I didn't select it. Select one of them, push E. Look at the side view. Now is this the one going to the bottom? No, that's the other. So we want to start with an offset, 100, no, -100. Yep, that's about right. And notice when you go too far, the hole comes out the side. So you need to go back to there plus a bit, because that area here will be too thin for your printer to print, and you'll get a hole in your fin. So we've done one, and go and select the other, make it visible again. Select the smaller hole, like that, push E, look at the side view, and we want to go offset up there somewhere, so it'll be another -80 or so probably, no, it'll be further, -120, something like that. Again, you want to go, well, let's get the offset correct, not quite that far, 110, so that's fine. So you want to find out where it punches out, and then come back probably 40mm or so. And that's your completed fin, ready for 3D printing. So to send to the printer, you would right click on the fin, save as mesh, and save it either as STL or 3MF, and then OK, and you will save it, name it whatever you want, and that'll save it to wherever you want on the computer, and you import that into your slicer. Good to go. One other thing you can do before you send it to your slicer is inspect it, do a section analysis, select the plane you want to look through, and then you can scrub up and down and see how close to the edges your holes are. So we can see here this hole is fine, That's the end of it there. We know it's 3.4 millimeter, so diameter. So this distance probably in the order of 1.5 millimeters. So we've got plenty of width for some epoxy to flow around. So that's it. Cancel that and send it to your printer.